2, 3.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Hussein Rashidi, metric number MA 13162. I'm here, I'm representing my fellow friends in my group to present on our topic or our project related on water rocket. Okay, as you can see in the whiteboard, there's a three diagrams related on how our project goes. Okay, at first you can see that is the launcher rocket, and second is the process where the deployment of our parachute, and third one is actually the time counted before the parachute went down or the rocket went down. Okay, I will explain briefly about the theory related on our project. Okay, at first, Newton's first law stated that object at rest will stay at rest, or object in motion will stay in motion unless acted upon by an unbalanced force. When the rocket is sitting on the launcher, the forces are balanced because the surface of the launcher push the rocket up while gravity pulls it down. When we pressurize the fluid inside the rocket and release the locking clamp, the force becomes unbalanced. A small opening in the bottom of the rocket will allow fluid to escape in one direction. Okay, one direction is mean that going to upward, or we can say it's a thrust force. So going to the opposite direction, allowing the rocket to propel skyward. The force continue until the pressure force the last of the fluid leaves the rocket. Okay. In Newton's second law, it stated that the acceleration of an object is directly related to the force exerted on the object and oppositely related to the mass of that object. So to get that water rocket to fly to great heights, we actually in our group we have brainstorming and has discussing on how to make our water rockets to fly to actually become the group the best group. Okay, to make the water rocket to fly to great heights. Okay, on our discussion we have stated that at first we need to minimize our rocket mass. Okay, minimize the rocket mass. Why? Maximizing the amount of force. Okay, at here we are minimize the rocket mass. Same time we are going to maximize the amount of force. But we need to be careful because when we minimizing the rocket weight, we don't want the rocket to be too light, because when it is too light, it will actually lose stability as soon as the water is expelled, and maybe it's going to turn end over end. Okay, at the same time, the greater the mass of the fluid expelled, from the rocket, the faster the fluid can be expelled from the rocket. So it actually create a greater thrust force of the rocket. They will make the velocity, or the rocket will fly higher and faster. Okay, increasing the pressure inside the water rocket actually produce a greater thrust. Like I said before, this is because a greater mass of air inside the bottle. Okay, greater mass of air inside the bottle escape with a higher acceleration. Okay, now I'm going to explain about Newton's law related to our project. For every action, there is always an opposite and equal reaction. That's what Newton said. Okay, like a balloon full of air, the water rocket is pressurized. Okay, we know that. Okay, when the locking clamp is released, fluid escapes the bottle, providing an action force. Okay, it provides an action force that is accompanied by an equal and opposite direction, which result in the movement of the rocket in the opposite direction. Okay, it means going upwards. Okay, essentially the faster the fluid ejected, and the more mass that is ejected, the greater the reaction force of the rocket. To actually increase the stability of our water rocket, we actually discuss on few consideration. Okay, at first we are going to add few fins. Okay, fins at along the rockets, which going to increase the surface area of the tail section. Okay, the wind forces will thus increase in the tail section, which in turn will move the center of pressure of our rocket towards the fins. In fact, that's the main function of fins. The larger the fins, the further back the center of pressure will be. Okay, our design